My voice is audible?
Yes, ma'am. Visible, ma'am. Your voice is audible on.
Then I will start.
Continue, ma'am.
Okay. Good evening to everyone. So Sir already gave the details about me. Just I will give you the few details about myself and our institute. So myself Hemavati, working as a scientist in CSIR Central Electrochemical Research Institute. So first, our institute mainly excellence in all aspects of electrochemistry and related fields for the development of globally competitive and eco-friendly technologies for industrial growth, energy and material conservation. And particularly my R&D area in our institute, the design and development of lithium-ion battery pack, battery management system and thermal management system for electric vehicle applications. And also we are doing we have a facility of cell fabrication, like a lithium ion battery cell fabrication R&D facility we have. So in that I'm doing the testing and evaluation of different cell chemistry batteries for performance evaluation. Come to the point, our today's topic is advancement in automation of battery technology. So everyone knows that today's world battery is one of the very essential key component in electric vehicle. Because of now everyone like in our India you can see in on road the few more electric vehicles, like lot of companies two wheelers electric vehicles you can see in our on road, and three wheelers and four wheelers you can see the few companies. So for example, two wheelers means you can see Ether Energy, Bajaj, TVS. So there are a lot of OEMs came. Now the more vehicles you can see in on road. So the very important and essential key component in electric vehicle is battery. Okay, so battery is like a electrochemical cell. Okay, it's like a combination of chemical energy and electrical energy. Okay, so we need to understand battery fabrication process and how its performance can be improvised in terms of automation. So that is we are going to see here. Okay, let's first let me just give you a brief outline. What are the things I am going to cover in our the today's lecture? So first I am going to give the overview of batteries and what are the histories of batteries are there and battery terminologies. So we know the battery is the energy storage device. Not only battery, there are different energy storage devices are there. So it's based on the energy consumption and power output. So we are giving I gave one comparison output for different energy storage devices. And what is the present and future technology? Okay, we know there are different batteries are there, like it started with lead acid and nickel cadmium, nickel metal hydride batteries, and now we are in lithium ion. And after lithium ion means there are different like lithium air batteries, lithium sulfur batteries. So there are different technologies came it's in R&D level. Okay, so now the present and future is lithium ion. Okay, then apart from lithium ion, we are like there are different chemistries we are integrated in lithium ion batteries to improvise the capacity of the battery, like energy density of the battery. Okay, the next, the lithium battery material advancements. What are the materials are there? So I said na, so lithium ion is started with the few cathode and anode material, but now there are several advancements are there. These advancements are why required? These advancements are required for to meet the application requirement. Okay, because of today's world we are using high power and high energy requirement applications we are using. Okay, in today's, for example, if you are looking EVs, electric vehicles. So two-wheelers, we can say the low power application, but you can consider the four-wheelers. So four-wheelers, you can see the in the Tesla vehicle. So in Tesla vehicle, like you can see the full platform. Okay, the full platform completely batteries. Okay, so why they are using that much batteries? Because of that much batteries are required to meet the that vehicle power requirement. Okay, so that's why we are just advancing lot of materials to increase the capacity or energy and power requirement of the battery. If you have a higher energy level or a high level of power batteries you have, the number of batteries is required in the application is will reduce. Okay, so that's why we are moving lot of advancement. The next, battery value chain. The next, come to the point, the automation in battery. Okay, how we are, for example, the battery manufacturing process, how the automations are improved performance, how it's provided through this automation of the battery, and why automation is required. Then battery production line, how we are manufacturing the cell. So in that process, how the automation process to include it to improvise the performance of the battery. Because of if you are developing if you are purchasing, because of, for example, battery production line, nearly more than 50 different processes are there. Okay, so if we are manually, if we are doing means, definitely somewhere, because of these are all the chemicals. So if you are handling everything in manual means, we definitely sometimes the output of the cell, some bad quality, you can't check the quality also, because of everything you are doing manually. Okay, but if it is automation is there means, definitely there is no manual like a manual process will be not there, and it should completely robotics process, and there is no human intervention also is not there. So definitely you will get the final product, definitely a good quality, and you can check the quality of the cell also. Okay, because of, if it is manual means, where the quality is missing, in which process the quality is going to down, so these are all very difficult to found. But if it is automation means, you can easily found the quality of the cell. So that's the main comparison between the manual process and this automation. And then remaining things are how we are developing the what are the process are there to develop the lithium ion battery or lithium ion cell, yeah, and how we are testing. So these are all things I am covering in remaining portions. So okay, the first we see about the batteries. So batteries, everyone knows, I think. The batteries are the most common power source for basic handheld devices to large scale industrial applications, because of we are using, started with the mobile phone, and end with you can say electric vehicle, or solar farms, or any other telecommunication. So where in all the places we are using the energy storage devices. Wherever you, if you need a energy storage devices, mostly that energy storage devices as a battery. We are using another different energy storage devices, but mostly you can see, like in our daily life, we are using the energy storage devices as the battery. Okay, and the battery can be defined as the its combination of one or more electrochemical cells, so that are capable of converting stored chemical energy into electrical energy. For example, when a battery is supplying electric power, so its positive terminal is the cathode and its negative terminal is anode. So what are the components are there? What are the parts are there in battery? Anode, cathode, and separator. And for conduction, we are using the electrolyte. So these are the important parts or important components or important materials we are using in the battery. So complete the battery performance is based on the inside the materials. So when we are, for example, when the battery is connected to the external load, the redox reaction converts high energy reactants to low energy products, and the free energy difference is delivered to the external circuit as electrical energy. But sometimes when a battery, if you are sometimes the terminal marked negative is the source of electrons that will flow through an electrical circuit to the positive terminal. So when discharging means the flow, which flow we are doing it, it's opposite to the when charging process. So that's the major working principle of battery. And next, the history of batteries. So history of batteries, I will give these are all like it started with the 80s, and it's like again there are a lot of implements is happening, and we came to the present market is lithium ion batteries. So for you can see here, first the battery, a name, the term battery is used by or invented by the Benjamin Franklin in 1749. Okay, because of that time when he was doing the experiments with the electricity using a set of linked capacitors. Then you can see the in 18th, the Alessandra Volta, he's the Italian physicist. He invented the true battery. His name Volta, its battery name is Volta. So it's stacked disc of copper and zinc separated by cloth soaked in a salty water. Okay, so these are all some primary batteries, and after that the zinc carbon battery came, and like you can see the alkali batteries. So now also we can see we are purchasing these alkali batteries from the supermarkets, and the after that the next technology as a rechargeable battery. It's a lead acid battery. So it's invented in 1859, and it's still the technology used to start most internal combustion engine cars today. So mostly now what are the vehicles now we are using, so you can see we are using the lead acid battery in that vehicle. So it's the oldest example of rechargeable battery. And apart from these rechargeable batteries, you can see the nickel cadmium battery, nickel metal hydrogen battery. So these are all also the rechargeable battery. Maybe you can see this batteries in your torches. So like a very small power application, you can see this type of nickel cadmium battery and a nickel metal hydride battery. And finally the present technology is like a lithium ion battery. So why lithium ion battery means compared with this all the batteries, like all the conventional batteries, so lithium ion battery has a high energy density. Okay, and lighter weight. So there are a lot of advantages there, and it's have a longer life cycle, and we can charge in shorter time. So due to these advantages, we are now using now the today's technologies lithium ion battery. And this is see 1980 the American physics professor John Goodenough he's invented a lithium ion battery, and now there are a lot of technology advancement came in that battery. So for example, lithium ion polymer battery, lithium sulfur battery, lithium air battery. So there are different lithium batteries, and these are all for give a higher energy capacity or energy density. And next, the battery terminologies. So these are all like common terminologies. So maybe okay, so these are all common battery terminologies. Maybe all the batteries, these are all you can see in all the batteries, these terminologies. So why these terminologies are required? Because of, for example, when you are purchasing one battery, or otherwise when you are going to for any R&D purpose or anything, if you are any product you are going to purchase, so you wants to know the battery, which battery you are going to buy. You wants to know that these all the terminologies to match the application requirement. uh, these all the terminologies where we can get from these all the terminologies is available in the data sheet. So for example, this is only for I'm telling for a lithium ion battery. If you are buying one lithium ion battery, definitely the data sheet will be there. So you have to first verify the data sheet. So what is the voltage, what is the current, and how much current we can maximum we can use that battery for charging and discharging purpose, and how many cycles it will give the it will give output from the battery. So what is the internal resistance? So everything we wants to know. Okay, we not like that we are just purchasing the lithium ion battery. So first we wants to know the every details of the technical details. So based on that only we can purchase that battery. That battery is definitely it's suited to that particular application. So here you can see the internal resistance. So internal resistance means resistance to the flow of current within the cell. So this internal resistance is a very important parameter. Because of this resistance only will like indication or otherwise will decide the performance of the battery, like health of the battery. Okay, for example, if you are testing the battery 100 cycles, the internal resistance is not much variation. So after 100 cycles, you can see that variation. This is just for example, I'm telling. It's based on everything. It's decided by the cell manufacturer who manufacturing the cell. So they gave 500 cycles, 1000 cycles, 2000 cycles. So they will fix that cycles and they will give that this many cycles you can use this battery. So after this, after 2000 cycles, it's your the battery will have a energy. The battery is good health, but it will not support that particular application because of that the power and the energy in that battery it will be reduced. Okay, so that's why this terminology internal resistances will decide the health of the battery, health of state of health of the battery. And voltage, so voltage is like a potential difference between the cells. Current is a rate of flow of charge. Capacity, everyone knows, basically battery we will indication is by voltage and capacity. So how much amount of charge stored in the battery, this specific energy, specific power, energy density, power density, these are all like it's based on how we can choose, means these are all is based on the application requirement. For example, a few applications like required a high energy, but some few applications requires a high power. Okay, so based on that only we can choose the battery. Okay, for example, you can see in EVs also, for like if you are driving in like a normal mode, like okay, so that time the current will be some continuous current. But sometimes if you are giving more acceleration and when you are starting the bike, so that times you will get more like you get a more current, and it will be like a pulse. Okay, 1 or 2 seconds it will rising into the pulse. So these are all high, these are all considered as the high power density. Okay, so everything, so a lot of things are there when we are choosing the battery for EVs. Okay, and the next the C rate. C rate is like what is the charge or discharge current as proportion of the rated capacity in AH, and constant current charge, constant voltage charge, trickle charge. So these are the different charging techniques. These are the standard charging techniques when we are using for charging the battery. And these you can see what are the different form factor of the batteries, like what are the different shape of the battery: cylindrical, prismatic, and pouch. So these are all available in market. So this is these are all three batteries presently available in market. You can see also. So how we are connecting these cells into the module. So if you are connecting the cells into the series and parallel, it converted into the module. So for increasing the voltage and capacity requirement. And once if you are assembling this module into the application, it's like a pack assembly. So here they gave only cells, but after that we need to add a BMS and the safety like safety components and the packaging. So there are several things are there, like the battery pack. Battery pack is like a combination of chemical, electrochemistry, electrical, mechanical, and thermal. So these all the fields will come in the battery. Okay, and The next, the comparison of power output for various energy storage devices. So I already said there are different energy storage devices are there. For example, you can see supercapacitor, flywheel, lead acid, lithium, advanced lead acid battery, sodium sulfur battery, zinc chloride, zinc bromine, and vanadium battery. So there are different batteries are there. So these batteries here we how it how it their performance, how we are comparing, it's based on the power output. Okay, how much it can support it, and the discharge time at a rated power. Basically, the supercapacitor, like we can discharge at a seconds with a higher power. Okay, so if you are comparing the lithium ion and the supercapacitor, lithium ion supercapacitor is the high power density. Lithium ion is the high energy density. So if you want high energy means you can use the lithium ion battery, but particular application require the high power means we can use the supercapacitor. So that's why they are giving the seconds. In just a few seconds, you can the supercapacitor will provide the very high power. And next, flywheel. So the minutes means we can use the lithium ion battery, lead acid batteries. So lead acid batteries, why we are presently not preferring means it takes a more time to charge, and it's like the life cycle. Okay, it's very less compared with the present lithium ion battery. Okay, then next, advanced lithium ion battery. So these are all different things we are classifying based on the UPS, and transmission and distribution supporting, and bulk power management. So the next you can see here, the automotive. So what are the applications are there? Automotive, we are using the energy storage devices. Stationary energy, for example, solar energy storage, we are using again on energy storage device. And here we are material handling. So there also the some energy storage devices there. Mostly we are using the batteries. And off-grid, off-road transportation. So for example, the trains and ships, there also some energy storage devices are needed. So so everywhere the energy storage devices needed to store the energy, and when we needed to use that energy in future purpose. So everywhere this energy storage devices covered. And next, the present and future battery technologies. So here, the all battery chemistries have further innovation potential towards 2030 and contribute to the decarbonization goals. So the major goal, we have to reduce the emission. So why the electric vehicle came in? So the main we have to reduce the carbon dioxide. So that's why here we mentioned the contribute to decarbonization goals in consultation with the CBI and Recharge. So you can see here graph, the technology changes in batteries are progressing toward high energy density. So this graph we plotted with the energy density with the different batteries. So lead acid, nickel cadmium, nickel metal hydride, lithium ion. So compared with these batteries, lithium ion have a high energy density. And you can come with the future technology. So future is lithium ion and zinc air, lithium sulfur, lithium air batteries. Apart from these batteries, we can add the solid state batteries. So these are all the present and future technologies. So then after that, different material chemistries also the scientists are working on in this research area. So how we can improvise the energy density of the batteries. Because of you can see the gasoline vehicle. Gas has a higher energy density compared with batteries. So how we can reach that gas energy density, that is the main part here. So this lithium ion battery almost reached equivalent with the gas. Okay, so that's a major point here. The major problem we are facing is cost, because of we don't have a presently the few industries started, and we have also the facility to develop the lithium ion cell or battery fabrication. Apart from that, we are importing the batteries from other countries. So due to this importing charges, the batteries cost is very high. Lithium ion battery cost is very high. But anyway, the compared with 2 to 3 years now, the cost is reduced. Maybe we have the facility. The India have the facility to. We have a plan to develop the cell fabrication facility. Means definitely the cost will be reduced compared with lead acid batteries. So that's the major problem, and the problem also presently going to rectify. The next, the we see about the material advancements. So I already said what are the materials advancements, because basically lithium ion battery, what are the materials we are using? Cathode, anode, electrolyte, separators. So what are the advancements started with the 2000 and 2013? So 30. So these are all goal fixed in our India. So how we can improvise the energy and the power density of the battery. So started with LCO and NMC material, LMO, LFP. So there are different materials, and finally 2030 its goal is lithium ion battery because of its very high energy density compared with the other chemistries. And basically in anode we are using the graphite, hard carbon. Then now we moved the lithium titanate, and now the lot of improvements happen, lithium metal, silicon alloys. So these are all the 2020, maybe in 2030 the anode materials, maybe we are using these materials. And the electrolyte, same thing, we are using the organic solvents, LiPF6. Presently then 2000 we are using, and mostly the LiPF6 only we are using it, but we changed the few things. For example, you can see the free electrolyte, gel polymer electrolyte. So these are the electrolyte, and what is the future means solid electrolyte. Okay, because of electrolyte means like a liquid, it's like a liquid actually. But if you are using the solid electrolyte means like there is no liquid, so there is some advantages there in solid electrolytes. There is no we can avoid that fire or some leakage. And separators, like we are using the polyethylene plus ceramic coating and cellulose non-woven. So these are all separators we are presently using. So how we are adding the more additive into the batteries, it will increase the performance. So that's the main thing here. We are showing the what is the goal in 2030. Next, battery value chain. So battery value chain, you can see here. So you can see here, this is basically the plant setup, how we are cell manufacturing plant setup this one. So you can see here what is the value chain. So the first step is raw materials. Raw materials means like all the cathode material, anode material, electrolyte. So all the materials will come here. And we have to taken into the raw materials as the battery materials. And the next, from this battery materials we have to design the cell design and the cell productions into the application. Which application? Either energy storage, EVs. Then once the retired batteries from application. So then once the warranty is over, or otherwise any damage will be happen in the battery, so that retired batteries we have to safely dispose by recycling and reuse. So these are all come in the battery value chain. Okay, so in addition to the raw materials, the value chain covers the production of chemicals, cathode active materials, cathodes, and battery cells and packs. So the batteries used in cars can be reused and the materials used to manufacture them are worth recycling for reuse. So these are all value chains. So and next we see about why electric vehicles. So basically now we see in the batteries. Okay, so now the come into the application. Why this all the developments happening? It's basically due to the electric vehicles only. Okay, because of batteries is already there, but presently why this much developments presently doing in India means it should it should support the electric vehicle. Okay, we have to reduce our conventional vehicle, and we have to increase on our on road of electric vehicles technology. So what is the advantages means, no conventional fuel, there is no need of petrol, diesel, gases, and cheap to maintain. It's more eco-friendly and lower carbon footprint. Basically, this electric vehicle to the main contribution is carbon dioxide emission. So reduce the carbon dioxide emission and less noise pollution, smoother ride. So here you can see the few comparison, the electric vehicles takes the hours to recharge, and we can minutes to refuel, we can do it. And you can see who is the electric vehicle manufacturing people, like this is a utility company and there is no emissions. There is the mileage range 100 plus, and this is 300 plus, 2 cents per mile and 12 cents per mile. Maybe this comparison, maybe some old comparisons, because of the present technology, it's very equivalent and more than a higher performance than gasoline vehicles. But the major problem we are facing the time to recharge, because of there is a two different charging technologies there. One is a slow charging, another one is the fast charging. So slow charging means, for example, the two wheelers, it take at least 5 hours to fill the charge. If you are putting the basically, if you are buying the two wheeler, they will give the charger, home charger they will give. So you can connect your charger in your home in night time. So you can, it takes at least 5 hours to complete the charge, and you can use it in daytime. But this is only for the particular distance you can use it. But sometimes suddenly we want to travel the longer distance. This is basically will happen in day-to-day life. So that time we need a common charging infrastructure to charge our vehicle. So that is the main our government focusing, the present focusing in the charging, developing of common infrastructure. Because of charging infrastructure is there. Okay, few companies, they developed in few places their own charging facility. For example, Bajaj means, so Bajaj, they have a charging facility in few places. So you can charge only your Bajaj vehicle. You can't charge other two wheelers, other two wheeler electric vehicles. For the same thing, Ather also, you can charge only the Ather vehicle. You can't charge other branded vehicles. So but the everyone, the people will it's like they wants the very customized one. Because of we already the conventional, this type of petrol operated vehicles, we are we are like we like we will go to the bunk, like petrol bunk means it's, we have to wait for 2 to 3 seconds and we will fill it and we can come out. But these vehicles are not like that. So people, we have to come into this picture, this electric vehicles part means we have to develop the customized charging infrastructure. Means definitely our people, like all one maybe easily accommodate into the this electric vehicle technology. So this is presently going on it. Actually, in our government mostly focusing on charging infrastructure to develop the common charging infrastructure for all the vehicles. Okay, so that's the main focus is going on it. The next, the business opportunities EVs. So I already said there are a lot of opportunities presently is there. See, because of the, you can say that started with the two-wheeler. Two-wheeler, there are two different two-wheelers are there. Like it's like a light duty and heavy duty, and e-rickshaw, four-wheelers, buses, and e-autos. So, and you can see these are all off-road vehicles. Maybe you can see in hospitals, airports, and malls. You can see these type of vehicles. Okay, and this is also battery operated vehicles. So there are a lot of business opportunities are there, and maybe the presently the 10 crores of vehicles will be electric driven. Among 30 crores of vehicles will run on road during 2030. And presently the Indian government, they introduce one scheme, actually FAME 2. So there they are giving the incentive to purchase the electric vehicle. For example, two wheelers they are giving, I think presently they are giving nearly 50, maybe 20,000 rupees they are giving. Exactly I don't know, but presently they the first they introduced that scheme, that time it's very less, then now they revised, so it's maybe very high, maybe a high amount actually. So I think 20 to 30,000 range. So these are all for two-wheelers, three-wheelers, even four-wheelers, even buses also they are giving the incentive to promote the electric vehicle technology. And the few programs also presently the some few government enterprises are they are doing for giving the employment and for giving the knowledge of the electric vehicle. Because of electric vehicle there are lot of areas are there. Okay, started with battery, motor driver, and we can say the temperature, thermal management, and the design of the vehicle. So there are a lot of areas are there. So they are giving the training and motivating the youngsters to give the more knowledge, and a lot of placements also happening in this area. So this is like the present strategy and present strategy for business opportunities. At the same time, we can say the R&D also. And next, the automation in battery. So automation automation in battery manufacturing is a decisive factor in a quality assurance. So it allows quality to be continuously and effectively monitored at each step in the process. So advanced automation process in cell development will help in performance increase and cost reduction, and it's very affordable. And maybe we can say a single bad battery cell is enough to negatively impact on entire battery pack. If because of we are using a electric vehicle, number of batteries we are using, if any one of the battery is bad, so the entire battery pack will definitely it will impact, it will get the impact and it will get the damage also. So the delayed quality control can result in high scrap rates, which would be reduced by reviewing quality throughout the manufacturing process. So that's why, like, if we are doing the manual means sometimes manually we are working on means it started with the battery have some bad material means we can't found that quality. So finally what will happen, the ended product also bad quality. So we will use that bad quality of the battery in a vehicle or any like interconnection with the battery pack means what will happen, it will affect the application. So that is the main problem when we are working on in manually. So that's why the automation is required to help to improvise the performance of the particular product. It's not only for battery, everything. Okay, for everything, if it is automation is required means it's definitely the quality, it should be very good. We can give the assurance for the quality. The next to why the automation is required. So I already said the higher production rates and increased productivity and more efficient use of the materials, better product quality, improved safety, shorter work weeks for labor, reduced factory lead times. So it will reduce the employees because of if particularly this battery fabrication process, it's like a combination of chemicals and and electrical and mechanical process. So it's combinations of everything is there. So chemicals we are using means it will affect sometimes the human body. So that's why they are telling if your automation involves means integrates the robotic into strategic areas to save time, increase capacity, and protect employees from dangerous conditions and repetitive labor. Applications for automation include, so basically what are the applications of the automation is assembly line, material handling. Okay, if robotics if you are integrating the robotics means there is no need of manpower to handle the material, and that's why the material handling is one of the application. And joining and cell test and load, measurement, conveyor, because of there are different processors are there. So once if you are finishing that first level of process, then after man handling is required to take that the first process material into the second process. So if you have a conveyor, some automatic conveyor if you have, means you can easily handle from first process to second process without human intervention. And automated guided vehicles, operator assisted stations, and inspection and testing. So these are all, maybe if automated means maybe we will there is no human intervention, and we can reduce the factory lead times also, and we will get the improvised performance product. So that's why here these are all like few process here you can see. We are using the ultrasonic mixing of mixing the materials, and dry painting, laser slitting, robotic manufacturing, calendaring, heat drying, slurry casting, and planetary mixing. So maybe these are all like this is like a current technologies, and this is the future technology, because of these are all manhandling. So once the mixing is over, then after we have to take by manhandling only we have to do the slurry mixing. Then after we have to do the drying and calendaring. So these are all like a manual process. But if you are it's like a, if your future technology means it's completely automatic. This automatic also reduce the cost also. So that's the major cost means how we can say, we can't say the equipment cost. We are adding all the cost. If you are doing the man handling means equipment cost is there, and man handling cost is there, and hours of time is also there. So there are a lot of things will be added. But here maybe if automation is coming means maybe equipment cost will increase, but there is no human handling, and and at the same time the timing of the production also will reduce. So everything will compensate compared with the manual handling. So these battery failures, basically the battery failures like internally. So I'm not telling the externally. If you are developing or fabricating a good battery, sometimes for example we can see in our lab also, we will coat the material for maybe 50 cells, means we can see some wasted batteries. Maybe at least we will get a 5% of that 5% portion, it should be a waste, because of these are all like handling of human intervention is there. So that's why in practically we can see this type of battery failures. So there are two different is there. One is a energetic, another one is a non-energetic failures. So non-energetic failures means sometimes if you are filling the electrolyte, if a human handling is there means some leakage definitely will happen. Okay, so cell swelling, if you are handling in human means the gas pressure we have to maintain in perfectly, otherwise the cell swelling definitely will happen. And the permanent safety feature enabled IR increase, that is internal resistance capacity loss. So energetics failures means once the cell will be over and we are taking into the testing, that time we can see the first charge and recharging process. We can see sometimes the cell will be fire, explosion, and venting. So these are the energetic failure, and these are all non-energetic failures. Okay, so next we see about the battery production line. So these are all like I said, na, nearly the battery. If you are fabrication or battery manufacturing process, will have more than 50 plus individual processes. So what are the categories are there means, first process is electrode manufacturing, and the second cell fabrication, and third is formation, and fourth is integration. So these are all different categories. The each category have a more number of processes. For example, electrode manufacturing means you can see start with the tube furnace and planetary ball milling, vacuum mixing, electrode coating. So these are all different sections. So like that, cell fabrications have a different processes there, and formation have a different processes, and the integration. So there are lot of the equipments will is there. So if we are doing this much equipments is man handling means definitely the quality assurance we can't give. But it is maybe automation means the time will reduce, and the output of that production also it should be a high performance, higher efficiency also. So that is this is like an overview of how we are making the battery. Okay, what are the equipments we are using? And then next to the following sense, we can see the process, how the starting and the few process I can give how we are making the battery from the chemicals. So first what we will do, then first process is like a mixing, like a milling, metering, or we can say the mixing. So here we are using the rotating tool. So in the rotating tool, at least two separated raw materials, like two separated raw materials. One is the active material, another one is we have to add some conductive additives, solvents and binders to mix. So this is like the rotating tool. Okay, here it's all combined to form as a called a slurry. So it will give the output as a some slurry mixer. So this slurry mixer like it's like a additive of this all the like you can see this active material, binder and graphite. These are all for cathode slurry, and for anode slurry, the active material will change, remaining will be same. So only the active material will be change for anode and cathode slurry. So this is the first process, and the second process is like a here you can see these are all manhandling. Okay, so the chemicals will be handled by the man. Everything will be handled by the manhandling only, and we have to put the weight also. So maybe here we can add this type of utilized advanced artificial intelligence or machine learning techniques we have to use. It means we can make all processes are highly efficient. And next is a coating. So coating means like the once the slurry is ready, the foil is here we are using two different foils. One is the aluminum foil and the copper foil. So these one is for anode, another one is for cathode. So the foil is coated with the slurry. What we have the first process we make an slurry. That slurry we will coat it here using an using in the desired tool. For example, here what type of tool we will use, like means slot die, and the blade we will doctor blade. So like that, this type of instruments we will be use. So here what are the automation we will use, means this is automatic continue coaster, like here air automation, hydraulic automation, centrifugal automation. So these are all automation process will be included during this coating process. So once the coating process will be over, so coating means it's like we are adding this slurry in the foil. So it should be two side, top and bottom. So once top side will be over, it's go after that that material should be it should be in next stage of the drying process. So once dried, again we have to coated in next side, that is another side. So again fed into the coating system by a manual transport process. So these are all everything in like a man intervention secured. So top side we have to coat, and again we need to remove it, and again we need to put it in foil, and next side we have to coat it. So maybe it's like a automated automation is there, means there is no need of human intervention, definitely will be not there. It automatically coat on top side, and next process will be going to the drying process, and again it will automatically come into the second that is next stage, it will be automatically will coat it, and the next stage is drying process. So once the drying process over, if it is the next automation is it's going to the calendaring. So here calendaring means why is required, means you first you coated and dried, the material is dried completely. So next process we have to clean. Sometimes the coating material will be not smoother. Okay, so that's why here we will use the calendaring. The calendaring machine is electrode heat hot rolling. So here all the coated materials will be the even thickness and cleaned also. So that's the main process here. So here that process we have to use some particular temperature we need to use it. So that's the next calendaring process. And the next process is once the calendaring is over, the next process is what we will do, the slitting. Slitting means like once okay, so next process is slitting. Slitting means so once calendaring will be over, so what type of cell we are going to do, like whether cylindrical, prismatic or pouch. It's based on that we have to cut the like cut the length and width of the cell, width of the foil. Okay, so for example, the cutting width of the rolls can vary depending upon the cell design and lies between 60 mm and 300 mm in many applications. So it's based on the application. Application also is there. At the same time, the form factor of the cell is also is there. So that is called as the slitting. So once the slitting is over, the next we have to do the tab welding. So you have a two different now foils you have coated foils you have. One is the anode and another one is cathode. So now we are adding the tab, positive for aluminium and negative for copper. So these are all tabs. You can see this is the pouch cell. So these tabs we are adding. So this is used for indication of positive and negative terminal. So once a tab welding is over, and next step is packaging. That is a separator we need to add. So this is positive electrode, negative electrode. So next step is we have to do the separator cutting, the same shape. So our next step is the ones stacking. Stacking means how many rolls you are required. It's like how we can roll it means during the stacking process, the separated electrode sheets like the positive separator and negative electrodes are stacked in a repeating cycle of first anode separator and the next cathode separator. So again anode separator, cathode separator. So that is the repeating process. So this is called as the stacking. So this is maybe we can call it as the Z folding. Z shaped folded separator. We can basically here we will use it. And the once the stacking is over, next what we will do means like we can say the electrode binding and the electrolyte filling and binding. So electrolyte filling means once it should be everything is over, it's called as a jelly roll is over. So here we are putting the cap. So before we are putting the cap, okay, just we are filling the electrolytes here. Electrolyte means it's like a liquid. So we are filling the electrolyte and after that we are crimping the battery. This is the final packaging of the battery. So this is the final packaging of the fresh battery. Okay, so now we have the batteries ready. So we come into the point of testing. Okay, so this is a fresh battery. So how we are doing the formation cycle means formation is described. Formation means the first charging and discharging process of the battery cell. Like a fresh battery I have, so how I can do the formation means that is the formation is called as the first charging and discharging processes. So that is the formation we will do it. This is basically we will do very lower current. For example, C by 20, C by 10. So like that we will put for formation and we will find the performance. You can see this is for example I gave here. So time versus battery temperature during charging and during discharging time. And this is for so once formation is over, we can do that cells for battery life cycle studies. For example, how you can do the battery life cycle studies means, so you have a fresh cell, you did a formation and you will get how much material you added in that battery. These are all manual calculation is there. Okay, first before you started this process, what basically the scientists will do, they have one calculation. Okay, for example, the output is 3 3 Ah capacity of the battery output is required means for that 3 Ah battery capacity they will add all the materials and finally they will put it in formation. What is the output they are getting? Okay, so that is the main part here. So once formation is over, so number of cycles they will calculate here. So different currents and they will put different currents and with the a lot of 500 cycles and 1000 cycles they will study it how the performance is varying. For example, up to 500 cycles you will get one capacity and after that 1000 cycles maybe the capacity will reduce or otherwise the capacity will maintain the constant value. It's all based on the cell health. Okay, how you are making the cell also here is there. Okay, so the lot of human intervention is there means if you are putting for 3Ah material in material but you will not get the 3Ah in output. Okay, if it is everything in its automation means definitely you will get the 90% of the cell capacity. But there are a lot of human intervention is there means very difficult to attain the 90% of the cell capacity. So that's the main thing is here, that's why we need a automation process. So after that what we will do, so battery safety, battery failure analysis, and life test, and health management, modeling, transportation. So these are all after that. Once the cell process and the cycling everything we measure, so after that we will do this all the processes. And we will check the mechanical degradation, failure analysis, and safety test. Because of what we did everything in electrical level, but mechanically that battery will be it's good or bad, that is we will test is like a safety test. Okay, so these are all here you can see these are all in available in market. This is called as a 18650 cell, and this is a 21700 cell. And finally, come to the point, the what are the research area in battery manufacturing? So computational manufacturing, it's a automation level, end-to-end solution, and multiple environmental. And I already said the FAME India scheme. So FAME India scheme, they are provide. It's started implemented over a period of 3 years. Started from 1st April 19, and they developed three different broad areas. One is the incentive. Another one is looking charging infrastructure and information collection. Okay, so these are all they developed these three broad verticals, and what their intention means, they wants to interconnect everything into this information part. Okay, so if you are integrate everything into the information part, you can like if everything will be cloud computing means, so all the things we can see. Okay, so who is coming for charging and how many times they charge that vehicle, so all the data will be monitored. We can get that information in through this cloud computing techniques. And this is also we can say one of the automation, maybe we can say it. Okay, and so this is I'm going to stop here.